Okay, so this is something that people make when you're trying to predict the type of decay. And again, most of the time they're only going to give you a couple of options because, you know, positron emission and electron capture have a net result of the same thing. Okay, so, but we're given beta decay or positron emission. Okay, so beta decay, that's going to increase our number of protons by 1. Positron emission is going to decrease our number of protons by 1. So thinking about this, and again, this is related to that neutron to proton ratio. So if I just kind of get back up here, beta decay is going to decrease the ratio. So we could say decrease NZ ratio. And positron emission is going to increase the NZ ratio. All right. So let's kind of go through this a couple of ways. Let's start with what we did before. So lead 192. Okay, so lead is atomic number 82. So that means we have what, 110? That is only, well, 1 point something. Hold on. 110 divided by 82. 1.34. And this is a really high number of protons, so we need to be pretty close to 1.5. So this is not saying whether it's stable. All these are going to decay. So here we have our NZ ratio is too low. So we need to raise it. So I'm going to say probably positron emission. You could also look at that and think it through, or you can look at the periodic table and you can compare 192, not 120, 192 versus, this represents the weighted average of the most stable isotopes there, so 207. Obviously, you know 192 is less than 207. When your mass of your isotope is less here, then you need more neutrons. So either way, we need fewer protons, more neutrons. So this is going to be positron emission. I tend to like the periodic table method, but I like to show you both ways. Okay, so here we also have lead. Here's 82, and this time it's what, 130. That's 20 more neutrons. Okay, so this comes out to 1.58. You can look at that and you go, oh, that's way too high. Remember, 1.5 is kind of our optimal there. So here we need to reduce this NZ ratio, so we need more protons, so it's probably going to be beta decay. Let's also do our little periodic table atomic mass check. 207 is the most stable. This is greater. This is the indication that it's too much. You have too many neutrons. You need more protons. So either way you look at it, you're going to get beta decay is what should happen. All right, xenon 114. Xenon is 54. Some of you snuck a look at that atomic mass too, didn't you? Sneaky, sneaky. All right, 60. All right, 60 over 54. What's that, 10 over 9? Indeed it is. 1.11. And something with this many protons, this is not close enough to 1.5, I don't think. So what we should probably do here is we need more protons. Oh, no, sorry. We need fewer protons. We need more neutrons. Oh, raise the ratio. So it's probably going to be positron emission, but let's just compare our atomic masses. It's 131. Once again, yes, we definitely need more neutrons. We create neutrons when we go through positron emission. If you don't believe me or you don't remember that, look up here. Positron emission creates neutrons.